Hi everyone, my name's Matthew Burns. I'm the project leader for B4, which is a partnership project all about understanding interactions between groundwater, surface water, and groundwater dependent ecosystems, or GDEs. This project is more of a legacy project in that it's pretty much wrapped up. And some aspects of it haven't been funded by the partnership, but there is still scope if there is interest to particularly look into the GDE aspect of the work. But most of the project is already wrapped up, and I'll give a short update on what we found in moving forward. This project came about because of two key reasons. So Melbourne Water, particularly through the work from Sarah Gaskell and others in mapping GDEs across Melbourne, have found that there are many and they're really important ecological and hydrologic features in the region, features that we need to make sure that we manage appropriately. And these features, GDEs, they're there because of important interactions between groundwater, surface water, sort of interactions that we really need to better understand if we are to manage GDEs appropriately. The other aspect of this project is all about stormwater infiltration. We know that urbanisation and the prevalence of impervious surfaces reduces how much rainfall infiltrates the soil. Less infiltration means less groundwater recharge, and that also means, and then that consequently means less stream base flows. So we want to promote stormwater infiltration as a way of making up for these lost base flows that are commonly observed in urban areas. The project, in terms of benefits to Melbourne Water, set out that if we did do the work on GDEs, which to date hasn't been funded, but there is scope to fund that later on, would have been to help identify GDEs that could be at risk of particularly water quality contamination. The thinking is that if we can better understand groundwater and surface water interactions and these GDEs across the region, then we would know locations where we certainly wouldn't want to promote, say, stormwater infiltration in areas that could have legacy water quality contaminants there, because there's a risk that those contaminants could be mobilised, get into the groundwater, and then find their way into these groundwater dependent ecosystems. The other benefit to Melbourne Water in terms of the stormwater infiltration side of things was importantly guidance on the practice of stormwater infiltration. Where are the best places in the catchment to infiltrate? How much should we be doing to potentially see a response of stream base flows? Should we be building large systems, smaller systems? Some really important sort of practical guidance on where's the best spot to infiltrate, how much should we be doing, and what are the potential benefits in terms of stream base flows of this increased infiltration. Because the project to date is only focused on the storm infiltration side of things, I'll just be talking about the aims related to that. And two key aims. The first was, what is the fate of infiltrated stormwater? We're building Melbourne Water, places around the world, investing lots of time and money in infiltrating more stormwater, but we really surprisingly have almost no idea on what the fate of this infiltrated stormwater is. And that's a real problem, because we don't know that all this effort is it actually recharging groundwater in the way we think? Is it having benefits in terms of restoring lost base flows? We really just don't know where this water is going, and that was one of the key aims of this project. The second aim was to work out, related to the first, when we infiltrate stormwater, how much of that water is consumed or taken up by downslope vegetation. We know that because we're infiltrating water in the top layers of the soil, there are these interactions with the vegetation, and there is some thinking that depending on what sort of vegetation you have, is it deep rooted or shallow rooted, this vegetation could play a big role in actually consuming the stormwater, potentially causing an issue that through the plants consuming this water, that's water that actually isn't going to deeper groundwater stores and potentially restoring base flow. So a bit of a conflict there. These project aims were explored primarily through a large ARC discovery project that the university, Tim Fletcher was awarded. And this project is kind of essentially that ARC discovery project. So to answer these questions, we focused our efforts on a large infiltration system in the basin, in the eastern suburbs. The infiltration system is known as the Wicks Reserve system. It is one of the largest systems in Melbourne. The basic, this is just a cross-section of the infiltration system and the monitoring setup. So for basically a couple of years, we did a whole lot of instrumentation of this site. We dug groundwater bores, we monitored water use on trees upslope and downslope of the basin using sap flow sensors. We also spent a significant amount of effort sampling water both in the infiltration system and in these bores downslope. And this water was sampled for some of the more common things like nutrients, heavy metals, but importantly, and the innovative aspect was to sample both the bores and water actually in the trees for the stable isotopes of water. And what that allowed us to do was to basically track the sources of water. So essentially, was water that's infiltrated from Wicks Reserve, was it actually being consumed by the plants? If we could track infiltrated stormwater moving into the subsurface and then into these trees, that would be some of the world's first evidence that on where this water is exactly going, and are these trees consuming infiltrated stormwater? So we're currently in the process of writing up a couple of journal papers which outline these results. I won't go into too much detail, but the key finding from Wicks Reserve is that during the warmer months of the year, there are big trees downslope, eucalypts. These big eucalypts are consuming most of the infiltrated stormwater. So, which is good for the trees, and there are potential microclimate benefits for increased water use in summer. But these trees, because these trees are consuming all this water during summer, it means that this plume of infiltrated stormwater isn't actually getting to the stream in the months of the year that we would really like it to be there. So really important sort of implications in terms of the practice of stormwater infiltration and our aims of trying to promote recharge to increase stream base flow. You can imagine that if the trees downslope of Wicks Reserve weren't these deep-rooted eucalypts and maybe some grasses or things like that, shallow-rooted plants, then much less water would have been consumed and much more would have actually made its way to the stream. But a really important and world first finding, really, that on this tracking the fate of infiltrated stormwater and finding that these trees downslope were actually consuming this water. That's in terms of sort of the quantity of water. At Wicks Reserve, we've also been tracking how the water chemistry is tracking in response to large volumes of stormwater being infiltrated. So we've been, as I said before, we've been sampling in these different bores downslope of Wicks Reserve in terms of nutrients and a whole lot of other water quality parameters. So this is an example of a chloride here. We're still sort of going through the final analyses, but in general, the water that's actually infiltrated from Wicks Reserve into the surface, the subsurface, is already a pretty good water quality anyways, because the system is doing a really fine job on water quality performance treatment anyways. And so what we're finding that because we're seeing potentially spikes in various water quality water quality parameters, we're thinking at this stage that legacy pollutants could be playing a role here. So the previous land use at this site was there's evidence it would have been previously agriculture. So it could have been, say, excess fertilizer use, these legacy pollutants that are already in the soil and have been there for some time. There is a potential risk that because we're infiltrating more stormwater, that some of these legacy pollutants might be mobilised. And we're potentially finding here at Wicks Reserve that there are some very site-specific issues at play here. But more will be discovered as we kind of go through the data. So next steps on this project, as I said, it's pretty much a legacy project in that it's pretty much it's finished, and the plan is to write a couple of journal papers and submit them this year on the fate of infiltrated stormwater, both in terms of the quantity and quality. And importantly for Melbourne Water, we've been promising for some time, and we certainly do it, is to write a practice note on stormwater infiltration based on our experience at Wicks Reserve. So again, coming back to the benefits of Melbourne Water, to be able to give guidance to Melbourne Water, to consultants, to industry on where could be the best place to infiltrate, how much, size of systems, etc. If Melbourne Water still interested in this question of looking at groundwater dependent ecosystems, there still could be scope, certainly within the partnership, in conjunction with someone, say Ian Cartwright from Monash University, to again better understand these groundwater surface water interactions and GDEs. So that's pretty much it for now, and I hope you found this talk interesting.